Hey guys, today we're doing Unit 1, Lesson 5, which is all about symmetry. All right, so let's start out with our vocabulary as usual. When we have symmetry, it means that the pre-image and the image coincide with one another, and that means that they meet or intersect at the exact same place. Okay, so coincide. When we have line symmetry, the figure is reflected over a line, and this is called the line of symmetry or the axis of symmetry. So it's reflected. And then rotational symmetry is when you rotate a figure and it looks the same as it did before we rotated it. A typical rotation is going to be between 0 and 180 degrees. All right, so let's take a look at some regular polygons now. And I'm going to flip my notes over. Okay, so the first regular polygon that we are going to start with is a triangle. So how many sides are in a triangle? 1, 2, 3. And then we need to determine both the number of lines of rotation and the number of lines of symmetry. So here's how we do the symmetry. Okay, line symmetry is if you drew a straight line right through it and you flipped that over, it would still look the same even after you flipped it. So there's one line of symmetry. Here's another one. And here's a third one. Notice that there's a line at each axis, or I'm sorry, at each vertice of the triangle. Okay, so there's 3 lines of rotation, or 3 lines of symmetry rather, and there's also going to be 3 lines of rotation. Okay, so you could take this figure and rotate this vertice up to that one, and it would look the same. And then you could do that for each of the 3 sides. So there are 3 lines of symmetry and 3 lines of rotation. Okay. All right, and then the angle of rotation, the way that we determine that is it is 360 degrees, which is all the way around in a circle, divided by n. N is going to be the number of sides in the figure. So here n is 3. So 360 divided by 3 is 120 degrees. All right, let's do this again for our square. So the number of sides is 4. Okay, and then our symmetry goes up and down, but also corner to corner. So there are 4 lines of symmetry, and there's also the rotational symmetry, okay? You could go corner to corner, or you could go center to center, either way. And then 360 divided by 4 gives me 90 degrees. Okay, we're going to do the same thing for our polygon, our hexagon, and our octagon. Okay, so this has 5 sides, so it will have 5 lines of rotation, and 360 divided by 5 gives me 72 degrees. Here I have a 6-sided figure, so there are 6 lines of rotation. So again, 1, 2, 3. So through each set of vertices that are opposite, but also through each of the opposite sides. So there's 6. 360 divided by 6 gives me 60 degrees. And then our octagon, 8 sides, 8 lines of rotation. 360 divided by 8 gives us a 45-degree angle of rotation. Okay, and so this works with any number of sides on a figure. So if you had a 15-sided figure, we would just call that a 15-gon. Okay, you could have any number of sides. And so you would just take n and n, however many sides is the number of lines of rotation and symmetry, and just divide 360 by the number of total sides. So let's take a look at a couple of practice problems, and then we're going to go ahead and do a Desmos activity. All right, so for our practice, we're going to start with the first 3. We're going to determine whether or not each figure below has line symmetry, and if so, we're going to draw all the lines of symmetry, okay, and tell how many. So let's look at our scalene triangle, okay. We're going to attempt to draw our lines of symmetry here. So that first one works pretty good, okay. What about the next one? So this line right here, you can see that the left side of the triangle and the right side of the triangle are not the same on both sides. They look different. So the answer to this one is no. All right. What about on our regular pentagon? So this was on the other side of our notes. There's 1, 2, 3. Where was our other side? Oh, I drew these wrong. Sorry. From each vertice to the opposite side. Okay, so there are 5. Let me do this in red. 1, 2, 3, 4, and 5. So that one is a yes. What about our kite? So I could draw, if this was finished all the way, there we go. I could draw a line straight through here and straight through there, and it would be exactly the same. Actually, no, there's just one line of symmetry. And I forgot to answer this question. There are 5 lines of symmetry. All right, let's take a look at the next set of problems. Determine whether each figure has rotational symmetry, and if so, give the angle of rational symmetry. So I have a square, and this was on the front side of our notes. So if I rotate this 90 degrees, it will still look like a square. So this is yes. I have an isosceles triangle. So that means that these 2 sides are the same. If I were to attempt to rotate this to here, it would totally change the way that my figure looks. Look at that. It wouldn't look the same anymore at all. So this is going to be a no. And then what about my equilateral triangle, where all 3 sides are the same? I would rotate this to here. So let's go ahead and do it. So I'm going to rotate that, and it looks exactly like the triangle that I started with. So I had to rotate that 120 degrees. Okay. All right, number 7. So actually, I'm going to pause for a minute and I would like for you all to try this, okay? In the space provided, sketch a figure that has the given characteristics. So for number 7, you need to have exactly 3 lines of symmetry. So go ahead and pause the video and draw a figure with exactly 3 lines of symmetry. All right, and I have drawn an equilateral triangle that has exactly 3 lines of symmetry in it. Let's do number 8 together, okay? Has no symmetry and no rotational symmetry. So I'm going to draw something kind of crazy. What about that figure? Okay. If you rotate this any which way, it's not going to be exactly the same. It's going to look different every way that you rotate it. And you also cannot draw a line across this anywhere. This side and this side are not the same. Okay. And even if I tried to do it this way, these shouldn't have been exactly the same. Okay, and now number 9, I need to draw a figure that has rotational symmetry of 45 degrees. So I need to figure out 360 divided by what equals 45. Okay. And the answer to this is 8. N equals 8. Okay, so you would do 360 divided by 45 to get your 8. So I need to draw an octagon. And I know that I am not good at this. So let's see. 1, 2, 3, 4, 5, 6, 7, 8. And there we go. That's my best effort. And it's got 8 equal sides, so it's an octagon. All right, let's look at number 10. A quadrilateral has vertices at these locations. So the first thing I'm going to tell you to do is plot those points. So 4, 0. Describe all of the reflections and notations or rotations that the map the quadrilateral onto itself. So the first thing that we did was we made the graph, okay, right here. All right, so we are going to say that this has 2 lines of symmetry. Here's a line of symmetry, and here's a line of symmetry. All right, and then how many degrees would I rotate this around so that it looks exactly like itself again? So I'm going to take my paper, okay, and if I rotate it 90 degrees, it does not look the same yet. If I rotate it another 90 degrees, it looks exactly the same way that it started. So I went 180 degrees. 180 degree rotational symmetry. All right, guys, that is it for now. Until next time.